So now that we've seen where these rules come from, where these equations come from for geometric sequences, we're going to practice writing the recursive and explicit rules and practice using them. So we have some vocab words at the top here. 3 of them we've already talked about. A sequence is just a set of numbers in a specific order. Terms of the sequence just means every number in that list of numbers that we have. And arithmetic sequence means we're adding the same number or the common difference every time. Now we're looking at geometric sequences where we are multiplying by the same number, which we call our common ratio, every single time. So there's a couple examples of what those will look like there. So the rules are written out here for you. And as a reminder, here's our definition of a geometric sequence. We are multiplying. The common ratio between each term is constant. And we can still use the 2 types of rules, explicit and recursive, but they just look a little different than our arithmetic sequences because we are now multiplying every time. So a sub n, we start with that for the nth term, equals our first term times the common ratio to this exponent of n minus 1. And when we actually write the rules for this, the only things that you plug in are a sub 1, your first term, and then you need to plug in the value of r, whatever number you're multiplying by every time. For the recursive rule, it's the same thing. We start out with a sub 1 equals our first term, and that's what you need to plug in, whatever that first term is. And then the second part of it is a sub n equals a sub n minus 1 times r. And again, you just need to plug in the value of r. So on either sequence rule, we are just plugging in the first term and the common ratio to write those rules. So examples, we have this sequence 3, 9, 27, 81. And we can see every time we are multiplying by 3. And that happens throughout the pattern. So our common ratio, r, is 3. So now we're ready to write our rules. A sub n equals, plugging in the first term, we have 3. Plugging in the common ratio is also 3. And then the exponent n minus 1. For the recursive rule, our first term, we start with a sub 1 equals 3. And then the second part of this, we have a sub n equals a sub n minus 1 times 3. And remember, we're just saying to find any term, we take the previous term and multiply by 3, starting at the number 3. Second example, we have 25, 5, 1, and 1/5. So if we're looking at this, you might think that we're dividing now every time, but we still want to think of it as multiplying. But if it's getting smaller, we're just multiplying by a fraction. So instead of thinking of it as dividing by 5, we want to think of this as multiplying by 1/5. And it starts to get difficult on some of these to know from your head what we're multiplying by. So if you're ever not sure, you can take any term and divide by the 1 in front of it. So we could have also figured this out by doing 5 divided by 25. This term divided by the 1 in front of it, and that gives us this 1/5 also. So that's how we find the common ratio if we don't know just by looking at it. Then we can write our rules. So a sub n equals, first term is 25. Each time we are multiplying by 1/5 to the exponent n minus 1. And then for the recursive rule, a sub 1 equals 25. Second part of this is a sub n equals a sub n minus 1 times the common ratio 1/5. And I'm going to let you guys try part C on your own if you'd like to. I'll put it on the completed notes, but we're not going to go through it on this video. Okay, so we have written the rules. Now we're going to talk about just finding terms in the sequence, sometimes using the rules, sometimes just following the pattern. So looking at this one, determine if the sequences are geometric or not. If it is, state the common ratio and find the next 3 terms. So if it's geometric, that just means we're multiplying by the same number every single time. So looking at this one, we go from -4 to -2 to 0 to 2. Okay, my head tells me we're not multiplying each time. If we're not sure, we can write -2 divided by -4. This term divided by the 1 in front of it, that simplifies to 1/2. Then we can go to a different one and do 0 divided by the term in front of it, which is -2. And that simplifies to 0. Obviously, these are not the same thing, so we don't have a common ratio. So I'm just going to write the word no, because this is not geometric. Then we have this one. We go from 1/4 to 1/2 to 1. This one, we can see we are multiplying by 2, and then we multiply by 2 again. So we do have this common ratio, r equals 2. So continuing that pattern, 1 times 2 gives us 2, 2 times 2 gives us 4, 4 times 2 gives us 8. So those are the next 3 terms. Then the last one, 100 to 10 to 1. Each time we are dividing by 10, but we want to think of it as multiplying. So we are multiplying by 1/10, or 1/10. And then times 1/10 again. So we do have a common ratio of 1/10. If we continue multiplying, 1 times 1/10 is 1/10. 1/10 times 1/10 is 1/100. And then 1/100 times 1/10 gives us 1/1000. So those are the next 3 terms for that one. Second set of examples, we have using the rules to find the first 5 terms in a sequence. So as long as we understand what these variables mean, this one's not too hard. We know the first term is 7. And we know that this rule tells us to find any term, take the previous one, and multiply by 3. So 7 times 3 is 21. 21 times 3 is 63. 63 times 3 is 189. And then the last one, 189 times 3 is 567. Okay, that was a recursive rule. If we use this one, we're using an explicit rule, but we know that first number is our first term, so we're starting at 50 this time, and each time we're multiplying by 1/2. So the next term would be 25. 25 times 1/2 would be 12.5. 12.5 times 1/2 would be 6.25. And then 6.25 times 1/2 would be 3.125. Okay, so we're just following the pattern there. In the next section, we have a given term, that we need to find for each sequence. So to do this, this one, we could probably just continue the pattern. It looks like we go from 1 to -2 to 4 to -8. If we are switching between positive and negatives each time, that tells us our ratio must be negative. So we are multiplying by -2. So if we continue that pattern, the next term would be -8 times -2, which is 16, times -2 is -32, times -2 is 64, and that times -2 would be -128. So there's our 1, 2, 3, 4, 5, 6, 7, 8th term, -128. We just followed that pattern. We didn't need to use a rule. This one, again, you could just list them out till you get to the 10th one, or we could write the rule. So we'll just do that quickly. A sub n equals our first term, 10,000. And this one, it's not easy, at least for me, to look at it right away and know what we are multiplying by. So this is one where you may want to take any term, so 7,500, and divide by the term in front of it. And when we do that, now I can see a little bit better that we are multiplying by 3/4 each time, or 0.75. And we'll check that if we do 5625 divided by 7,500, that also gives us 0.75. Okay, so there is our common ratio. That goes in here. And we are multiplying n minus 1 times. So now if we're finding the 10th term, that means we are taking 10,000 and multiplying by 0.75 to the exponent of 10 minus 1. And we can change that. 10 minus 1 we know is 9. So exponent 9. So now at this point you would just type that into a calculator.
Here's a reminder, Michaela is available for...
So I will pull up my Desmos calculator and type it in just like that. 10,000 times 0.75 to the exponent.
Sorry, Michaela's
9.
only available by phone or text, not email. Phone or text.
So 750.84 is our answer. Rounding that, we can just write 750.85 for our 10th term. Okay, and then that leaves us with just a few more examples. So everyone we've looked at so far was easy to tell the common ratio. This time it's given to us, but what we don't have is the first term. So a sequence's third term is 1,458. The common ratio is 3. We need to find the first term. So we can just think of this as working backwards. We know our third term is 1,458. And if we're multiplying by 3 every time, then we need to work backwards and divide by 3. So what number times 3 is 1458? If we take 1458 and divide by 3, that takes us to 486. And then we need to do it one more time to get our first term. What number times 3 is 486? So take 486 divided by 3, and we get 162. There's our first term. Part B, we have a sequence's first term is 3, and its third term is 48. So first term is 3. We don't know the second term. We know the third term is 48. So for this one, all we're looking for is the common ratio. We know to get from 3 to 48, we are multiplying by that ratio, and then we're multiplying by that ratio again. So we are multiplying by r 2 times, which we could write as r squared. And then what is that number to get from 3 to 48 that we would be multiplying by? So take 48 divided by 3. And we get 16. So r squared equals 16. To undo this squared to figure out what r is, we just need to take the square root of each of those, and we get r equals 4. Or it could be -4. So that one's kind of tricky. We don't know if we multiply and get a positive right there or a negative number right there. So either one of these is possible. But we could then find our missing term if we take 3 times 4, we get 12. Or it could be -12, so I'll just put plus or minus there. And then to get the next term, 12 times 4 gives us 48. So we did get the right common ratio. Last one, the sequence's first term is -1. And its fourth term is 125. So now on this one, we are multiplying 1, 2, 3 times r. So that tells us we have r cubed. And divide these, we have 125 divided by -1, which is -125. So to undo this cubed, we have to take the cube root of each of these. And that gives us r equals the cube root of -125. We haven't done this a lot, but we can do the cube root of -125, and the answer is -5. So our common ratio on this one is -5. Okay, so these notes will be posted on my Canvas page if you want to look over them and use these examples to help you with the IXL and with the backpacks assignment. And if you have any questions, let me know. I will also be available for office hours on Friday this week. Thank you.